Okay, thank you.
โอเคครับ so this is what is called item set. Okay, the basket is the item set. It's the set of items. So you would see various words like if you want to Google frequent item set, market basket analysis, or something like data mining. Okay, data mining is a more it's doing something like this, but not just basket analysis. It's doing all kinds of relationship finding. So I would consider data mining to be a form of unsupervised learning. Okay, because you get the data and then you form analytics, and then you produce analytics, and the data, there is no right or wrong answer, right? Because you try to find what the data is like. You find the histogram, you find, so I could even consider statistical method to be a form of unsupervised learning. Okay, but I don't. The reason I don't is because this thing is 300 years old. This thing is only 50 years old. Okay, so to say that this is a part of that is a little bit rude. It's a little bit rude. Okay, so I'm not going to do that. Okay, now in statistical method, there's no right or wrong answer because you literally just trying to find the best fit. Now you can say in statistical method, you can say probability model A fits better than probability model 2. Okay, you can say that. Okay, but you can't exactly say it's wrong. Okay, but okay, so I want everybody to look at these two statements. In statistical method, you can say probability model 1 fits better, but certainly you can't say it's wrong. So I could even consider statistical method to be a form of unsupervised learning, but I'm not going to do that. Okay, this is 300 years old, 400 years old. This is 50 years old, so I'm going to erase this. But certainly data mining is about maybe 80 years old. Okay, and this is like 50. So I guess I can do that. Okay. So Google this at home. So that's that. So one thing we do is one more thing from linear algebra. Okay, and now to data mining in IE frequent item set for market basket analysis. Okay. Okay. Right. So do that. Now let's go to this one. 2. Cluster analysis. Now this is where I want you to take two sets, but let's take this one first. This one first. Okay, so there are three things I would consider. This. Okay, good. Okay, so that's all the side notes that you need. Okay, so cluster analysis. So let's go to cluster analysis. This one. Okay. Okay, don't save. I'm not saving this. I don't know if you want this. Maybe you do. Okay, I should save this just in case you want. Save as. Boom, 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 boom. Work. Student. Courses. And big data analytics. And bits and pieces. Okay. Now, let's start clustering analysis. Okay, cluster analysis. So first, let's download this data. This is going to take 2 seconds. Okay. Good. Some weird reason. Okay. Okay. So you guys remember this data set? Okay. This is what? Okay. Old faithful data set. Now let's see what it looks like. Okay. So this is the, I don't know why it does have this. Oh, processing mode prediction. Okay. So it's giving all the eruption. Okay. But it's not just giving you the time of eruption, it's giving you time of eruption and the waiting time. In other words, it's something like you wait 79 minutes to see 3.6 minutes of show. I think this is what this is. Okay, so example data statistics or faithful. I don't know why I keep having this. Oh, I must have included something. You know what? I think I accidentally opened something. Let me just close this, close everything, and start again. Okay. Okay. So supervised learning, unsupervised learning. Okay. Okay, so that now, on it. Okay. Again, so this, the x-axis is the duration of the eruption. So about between 2 minutes and 5 minutes. But this is your waiting time. So there is a bit of a correlation between the longer you wait and the longer the eruption. Okay, but that's not what's interesting here. Okay, that's not what's interesting here. What's interesting here is that last time we did this kind of histogram, right? Like a kind of two-dimensional. But just to look at this data, you can see that there are two clusters, right? Okay, so concept of cluster. So think of concept of cluster. Side note, side note. Okay. If you visualize in 2D, you will see that the data 2, seem to cluster, form 2 cluster. Okay, there could be more than 2. Okay, but in this case, you could form 2 cluster. Now, what do you mean by cluster? Well, if you, let's call this cluster 1, call this cluster 2. Okay? In each cluster, data points are close together. Okay? Between cluster, data points are far. Yeah. So in fact, it's not between cluster. Cluster themselves seem to separate. Okay. Now let's make life difficult. This is easy, right? You can say that this and this. My question is, what about this guy? Let me make it larger. Okay. This guy, does he belong to this cluster of wait an hour, watch for about 2 minutes, or wait about an hour and a half and watch about 45 minutes? It's not clear. It's not clear. So we have to give some kind of criteria. Now, the most obvious criteria is, in this case, so criteria for forming cluster is equal to distance. Okay, that makes sense. That makes sense, right? That makes sense. By the way, this is called schema. Let me give you an example. Okay, let's say you have spaghetti and you have noodles and you have salad and you have fork, you have chopstick. Okay. Okay. If I ask you to likewise form a cluster, okay, you would have to separate into schema, types of items. Okay. So how would you do this? You would come to this and you say spaghetti and noodle and salad together, and fork and chopsticks together, right? Okay, and this is spoon. Okay, and maybe soup. Is this correct? Now, is there another way? What if your schema, things, items appearing together on a dinner table, okay, or used together? Would you do this? No, because you would never, well, you can see soup and salad, let's say, okay? You can see this together, but what this means is that you would use what with what. So actually, a better way of doing this organization is this. Okay. Now, once again, this is a form of unsupervised. Well, it's not machine learning because you're doing it yourself. There's no right or wrong answer. It depends on what you choose as your schema, right? If you're going to organize by types of item, obviously this is food. Food versus utensil. Okay. How about this? How about dish? Dish, right? So you would use spoon because you want to eat soup. You use chopstick to eat noodles, and you use fork to use salad. You never use fork to eat soup. That doesn't work. Okay? Chopstick with salad, well, it works, but it's not polite. Okay? So that's why there's no right or wrong answer, right? Same here. We're going to go back. Side note on schema. Yeah. If grouping, okay, but if schema is this, then grouping this. Okay, so side note and schema. So criterion. There's only one criterion. Okay, so that's the criterion on distance. Now, let me make life a little bit easy, more difficult. What do you mean by distance? Okay, if you talk about Euclidean, okay, this, okay, that makes sense, right? Okay, let's look at this one. Okay, the distance, Euclidean distance is what? X1, minus x2 square plus y1 minus y2 square, and then you take square root the whole thing to the power of 6.5. Right? That makes sense, right? So Euclidean distance close with respect to this. Okay? And that seems to be the obvious thing, right? But now I'm gonna show you a different case. What about, and I'm not gonna bother drawing, so I'm gonna go to the internet, cluster analysis. And there should be some picture that I can use. Let's see, this is there. Okay. Okay, come on. Okay. Okay, this picture, let me zoom in. Okay, this picture, notice how the cluster is made. It's a little bit like a river running through population, right? So people are sort of like gather on the island, people are gather on the bank, and this is kind of like separate. You say that this is one cluster, this is one cluster. But this is not closeness by Euclidean distance, because certainly this guy is closer to this guy than he is to this guy, correct? This one, that's about a kilometer. This is about 300 meters. And yet you would say that this is one cluster. This is one cluster. Now this is clustering based on density. It's like a contiguous mass. So it's about distance, but it's about distance to the person, to the person, to the person, to the person. So even though this distance is a kilometer, this tiny distance is about 10 meters. So if you can make 10 meters at a time, you can take 10 meters jump and you can get to everyone. That's one cluster. This guy, you can never get by one 10-meter jump because you have to cross the river, right? So it is a distance, yes, but it's not a global distance, but it's a sort of like a population distance, okay? So this person is closer to this in absolute distance than this person is to that. But to get by 10 meters at a time, this person can get to here, but not to here. Okay? So there are two schema. So there is, for our purpose, there's a distance-based clustering. And the other thing, which is also using distance, we'll call it density. Okay, density-based clustering. Today, I think we'll just have time to cover the distance-based clustering. Okay. So let me show you. Actually, there's a nice page on. I think Python also has this. Okay, let's go. I think Python has a nice scikit-learn. That's a nicer picture. Ah, there it is. Yeah, this is a picture that everybody uses. So let me put that in here. And your class note. Check out. Okay. You will see that in this case, okay, now using your eyeball, you can obviously do a better job than a machine. Okay, this is what the machine does. It's separating by colors. So what it does is it's separating a cluster by different colors. Now, obviously, to you and me, it would make sense to say this is an inner ring, this is an outer ring, right? Now, this one does best because this one happens to be density-based algorithm. So it's this, so it's this. So it nicely separates the inner here from the outer, even though, again, this distance from this point to that point is very far, but you can get a small step to it. So this is density-based algorithm, works best on this, okay? But this one, say, k-means, where's k-means? Simple k-means. Okay, this one is might as well call k-means. Okay, it's going by distance. So it's separating by who's closest. Okay, but you have to make a big jump across the river. So different kind of data, different kind of manifold, different kind of feature work best with different kind of algorithm. Now, obviously, if it's separated nicely like this, then it doesn't matter which algorithm you use, it's going to do the same thing. So these are all different clustering methods. Okay. So there's clustering method, i.e. k-means, i.e. BB scan. Okay. This scan with an S, I think, without an S. So these are the two most popular algorithm. Okay, and there's also there are various techniques to it, but that's what we want to do. So again, once again, with Mathematica, simplest, the basic approach are built in. Okay, and you don't really have to specify which. Mathematica will essentially try them all and pick the best one for you. Again, there are different based on criteria. Okay. So in this case, okay. Mathematical essentially run them all, as roughly speaking. Okay. So likewise, we are going to find the cluster. Now, again, originally we have this thing, right? We have this thing, which is kind of like a bunch of numbers, right? So it's going to try to find cluster. So what I will do is I find cluster. Now, I can do this and say method, okay, is, okay, and there'll be a list of methods, DB scan, Gaussian mixture, Jarvis, Patrick, you know, but if you didn't put, so you can do that, So you can say, okay, let's say I want to use agglomerative. Agglomerate is also very, it just, so you can do this. Okay, but then has to specify So do the same thing, except you just omit it, or you can do this. Yeah, it's the same thing. If you omit it, it's assumed it's automatic. Okay. So let's find out what that gives you. That gives you okay. There. Notice there's another bracket. See that? So this bracket is gonna separate the first group, which goes all the way down to somewhere here. Yeah. So this is the first group, the first cluster versus the second cluster. Now, so what we should do is just name it. Cluster of all faithful data is equal to this, and then I do a list plot. Now, automatically, list plot would give different colors, right? So not originally you have X, Y, Y, right? A whole bunch of them, right? So it's gonna give you just this. But if you put a bracket around the first one, and then you have another group, okay, it's gonna highlight different colors. So the first group, I think the convention is blue and yellow or something like that. Okay. So that's the first group, that's the second group. Now, what this is giving you is clustering the data. Clustering the data. Now, in real life, right? Once you cluster the data, this data, you cannot always plot it. Okay? The reason we can plot this is because it's a two-dimensional data. If it's a three-dimensional data, you can plot it. Okay? And if it's n-dimensional data, you can't plot it. For example, and this is the example that if we have time, we'll get to example number 3. That's example number 3. The third data set, the data set from COVID. This guy, okay? If you work from this data set, now this data set is a little bit like if you go to World Odometer, I think, something like that, right? And you go to coronavirus update, okay? And you see that different countries, okay? Different countries has different response rate. Okay, so if I'm going to look at, okay, I can do this, and if we have time, we'll get to it. If not, we'll do it next time. So if we take just 2 variables and we plot all the countries, you can imagine that we'll get something like this. So this is cases per total cases. This is total death, and maybe there's some kind of distribution here. Maybe there's a cluster of low case, low death, and high case, high death, or high case, low death, but low case, high death. Maybe you get all 4, okay? But the point is, you can do that with just 2 dimensions. What if you want to add something else, like hospitalization, you know, all kind of stuff? And that's what our world in data gives. So when you go to our world in data, if you go to their COVID database, it gives you a lot more items to play with, like hospital bed or something like that. And that is essentially what this thing loads. Okay, this is loading our world in data. OWID, that's our world in data. Okay. But anyway, let's go back to our simple example. So we can plot this, right? We can plot this. Now, so this find cluster literally just cluster your data. But what about this? What about this? Now, okay. Now you find you have two sets of data, right? In fact, let's do this. Length of, okay, there are two, right? So if I take the first one, okay, take the first one, okay, take the first one, comma. Now I want to look at, let's say, eruption time. Eruption time is the first element, and all is all the data set. Yeah, right? Oops. All, so sorry, all one. Okay, so that's basically all the eruption time for the first cluster. But for the second cluster, it would be this, right? So obviously, if I want to compare the mean, I can do this. Oops. See? So this is an average, okay, of the first cluster. The first cluster is this guy, this blue. And I take the first element, which is the eruption time. The average of this comes down to 4 minutes. But for the second cluster, I take all the data. I take the first element, which is the eruption time. I take the average, and I get 2. Now, if I wanted waiting time, I would obviously take the second column. Okay. Oops. Okay. Mathematica doesn't like to give you a. Okay. Okay. So for the first cluster, you have to wait on average 80 minutes. For the second cluster, you have to wait on average only 54 minutes. So, you know, sometimes you wait a long, so that there's nothing in between. There's rarely anything in between. And that data point that I was asking you earlier, the algorithm decides it's closer to this. Now notice there's some a little funny criteria. Look, there's a little bit of yellow here. I don't know why. Okay. So again, there's no right or wrong answer. If I apply this to a different criteria, like a density base, it may say that, you know, this thing is 1 density, but this is lower density. I don't know. Okay. So there's no right or wrong. It depends on your schema. Okay. It's like right here, there's no right or wrong. Okay. If your schema is food versus utensil, this is your grouping. If your schema is things that are used together, this is your grouping. Okay. Now, okay, so that's that. But what if, okay, what if you want to do some kind of evaluation? In other words, this is your past cluster. I want to know if I have a new data point. In other words, today I just went to Old Faithful, and I waited. Okay, and I waited for 7. Say I want to know that I have this thing. Okay? I happen to have on a given day watch a show that lasts 3.2 minutes, 3.4 minutes. But before that, I have to wait 71.2 minutes. Okay? My question is this point. which cluster does it belong to? Remember, the blue one is like a big cavity, right? Lots of water, wait a long time, erupts a long time. Yellow is like small, cavity, wait only an hour, but get about 2 minutes of show. So this may look like a long, okay? So this may put you in here. But what if it's something like not so sure, something like this? Now you're beginning to have doubt because it's some kind of in between, right? Well, let's say we have some number like this. Okay, let's just say this is your day. The question is, you want to know which cluster that belongs to. In this case, you don't want to just create a cluster. You want to do what's called find cluster as a function. Okay, let me show you. Find cluster. My O faithful data cluster finder equal to, oops, not my cluster. I want to use different function called cluster classify. Okay. So now you don't get a value, you get a function. Okay. Get a function. And if you click down, it's actually giving you what method it does. Now, if I did this and I say method is conglomerate, it's going to give you conglomerate. But because I omitted it, it tries all the method and it said the Gaussian mixture method is best. Okay. So now I want to say, what's my cluster? Where's my data? Where's my okay? Today I went to this. It belongs to cluster 1. So if I had put this in here, it would belong amongst the blue. Okay? Let's make another obvious example. Let's say shorter time, and shorter, about 1 minute, and I wait about 40 minutes. I bet this is going to give you 2. Whoops. No, actually no. Weird. Hold on. Okay, let's make it really short for some reason. I think I screwed up something somewhere along the line. Hold on. I messed something up here anyway. Sorry, but basically, if I put in cluster classify, it's supposed to let me try something. Hold on. Let me force to conform it. Something strange. Okay, it has to be. Oh, okay. Yeah, I don't know what happened when the Gaussian mixture didn't do so well. I don't know. Kind of weird. But anyway, so this one, because it's a short time, short wait, it comes out 2. But this one is a long time and long wait. It's giving 1. Okay. So basically, it's finding where it is. Now, in reality, what you would do is this: you would find out the cluster. Okay, you would do what's called radar report. I'll show you guys a bit later next time. Basically, you want to know where is this cluster. So instead of just reporting the whole cluster, you would find the mean and the of each axis. Okay, so we'll call that the centroid. Okay, so you define once you find cluster, once you separate data points into cluster, say, let's say you have K cluster. Okay, each the average values in all dimension, okay, for each cluster is called its centroid. In other words, the centroid of this cluster, okay, let's say I did this cluster data. Hold on. Oh, cluster over. Okay, so this one here is the mean of the dimension 1, and for the dimension 2, okay, so this here is centroid 1, okay, and centroid 2 is equal to average for the first dimension and the second dimension. Okay. So that's the centroid. In other words, if I plot 4 and 80, it should be somewhere here. If I plot 2 and 54, it should be somewhere here. And those are the centroid. Okay. So in reality, right, you have thousands of data. Okay. Just like you have a whole bunch of data set, you would, if you, okay, let me put it this way. Just as if you get one set of data and report the mean and standard deviation, etc. If you get a set of data that cluster, form cluster, you would report, okay, the mean for each cluster individually. Okay, that's basically it. Okay, that's basically it. So you would look at the centroid, and that would be how you organize. Now, this is useful, even though, you know, there's no right and wrong. Like I said, look at this picture again. Yeah. Now, in this case, you know which one is better, right? But in reality, if you do this in high dimension, there's no way you can plot it, right? You can only plot 2 at a time, so that's not good, right? The point is you can always cluster, and so these are the main one. K means and BB scan are covered in the cluster. Okay, so this is sort of like same thing as this, right? But I tried different method. So it's the same thing, right? Same thing. Now, the automatic is the first one. Second one is agglomerate. The third one is DB scan. So it's giving slightly different. Okay. So this is the cluster classified. This is the one I was trying to show you earlier. Now, the nice thing is you can cluster even colors, right? I just create a random color and ask this thing to classify colors. Where's the color? Where's the color? Where's the color? There. See? You will notice that this is sort of like a pale color. This is sort of like a hot color. I think it's long here. So random color. Let's make a random color. Okay, and let's list them. Songs. Okay, so where's my color? Okay. Now, there. I just one more. So this is one set, right? So you can see this is sort of like the greenish. This is sort of like the light blue. This is sort of like hot brown, and it's kind of purpley. This is kind of nah. Okay, this is kind of like dirt. Okay, so it's trying to find cluster even when the object is colors. Okay, well then obviously that's doable because each object color is actually a triplet of number: 0.83 red, 0.63 green, and 0.12 blue. Okay, so you can do that. So this is cluster analysis. Okay, cluster analysis. That's it. That's it. Okay. So I want for homework. Okay. Try to plot. List plot your your data. List plot your data. Now find. And I'm going to give you a day or two because I want you to go back to your old data set. Homework, go back to your old data set. Okay. Pick two numerical variable of interest. Okay. Right. So it's going to look something like x11, x12, x21, x22, xm1, xm2, okay, something like that. Okay, so assume in this case you run find cluster, right? Does it have S? I think it has S. Does it have S? Find cluster me at S. Okay, find cluster. Okay, find cluster. Okay, and then do histogram. Okay, do histogram. That's it. So that's very easy. Show histogram. Now for bonus, you can try to specify method and choose different name. Okay, can even use manipulate. Okay, so if this is my list, say this is my, okay, if my list of method is something, yeah, I'm just gonna forget that. Okay. Okay, say method list equal to, okay, cows, okay, VB scan and no, say something like that. Okay, whatever. Now you can copy this from the data. So I'm going to put this thing in the line group right away. So you have document work and I'll give you both the this thing and this thing, data mining and unsupervised learning. Okay. Good. Okay. So this everybody will be different. Okay. But if you use this, will be even nicer. Okay. So I want to finish class there because I want to have an open discussion. จริงนัดปิดเซฟก็ได้นะตอนนี้ก็ไม่มีอะไรแล้วเดี๋ยวจะคุยกับน้อง